Today, we'll look into the different ways AI learns and adapts. We'll explore the differences between supervised, unsupervised, and reinforcement learning. We'll also look into exciting real-world examples to see how these methods are put into action. So let's jump right in. First up is supervised learning. Just like when you are teaching a child by showing them a bunch of labeled pictures, a cat, another cat, a dog, and another dog, in supervised learning, the AI is like the child. It learns by example. Some popular algorithms for supervised learning include linear regression, logistic regression, decision trees, random forest, SVM, and k-nearest neighbor. Linear regression is good when you are predicting continuous outcome based on a linear relationship between the input and output variable. This is useful for use cases like predicting house prices based on several factors, like number of bedrooms, floor area, location, and more. The model can learn from previous house pricing and predict how much another house will cost. Logistic regression is good for binary classification because it predicts the probability whether input belongs to a specific class or not. Then there's decision trees, where decisions are made on a tree-like structure, and random forest, which is essentially an ensemble of decision trees that works together. Then there's SVM and k-nearest neighbor. Now, each of these algorithms works best in certain situations and certain datasets. Some perform better than others depending on the situation. So using the right approach would vary depending on the problem and the dataset that you are working on. And some of the most common applications of supervised learning include spam detection, fraud detection, image recognition, and sentiment analysis. All of this works well on supervised learning because there are existing available datasets where the model can learn from. For example, spam detection would have existing datasets of previous spams and not spam emails. Same with sentiment analysis and fraud detection. The advantage of using supervised learning is that there's high accuracy, it's interpretable, and it's versatile. However, supervised learning would require a lot of labeled data in order to perform properly. It may also be prone to overfitting if your training dataset isn't that comprehensive. And it's time-consuming because it will require a lot of time for you to prepare the data. Next up, we have unsupervised learning. Here, the AI likes to venture into the unknown territory without a guide. It finds patterns and structures in the data all on its own, without any labeled example. Unsupervised learning techniques like k-means clustering, hierarchical clustering, and PCA help the AI group data into clusters based on similarities. And here's how they work. K-means clustering data into K clusters. The model looks for data points that are close together and group them into a cluster. Hierarchical clustering is also another form of clustering by creating a tree-like structure of clusters based on their distance. Then there's PCA, or Principal Component Analysis. This is a dimensionality reduction technique transforming data into a new set of variables that captures the most variance. So if you have a set of data with 100 columns, you can use PCA to reduce that into less than 10 and still get the same result. Unsupervised learning is useful for use cases like recommender systems, customer segmentation, document clustering, and genome analysis. In recommender systems, you can use algorithms like collaborative filtering to suggest products or content based on user behavior. By clustering similar users together, the system can recommend items to other users in the similar cluster. This allows businesses to tailor marketing strategies based on the different customer segments, thereby improving customer satisfaction and sales. Similar algorithms can be performed for document clustering, so that you can group similar documents together. In genome analysis, learning can help identify patterns in genetic data to discover new biological insights, and using techniques like PCA to help reduce data complexity while preserving important patterns. The beauty of unsupervised learning lies on its ability to discover hidden patterns, making it excellent for data exploration. However, results can be hard to interpret, and it might not work well if there are no clear patterns. And last but definitely not the least is reinforcement learning. Picture an AI learning to play a video game. It interacts with the environment and learns by trial and error, receiving rewards and penalties based on its action. Reinforcement learning uses techniques like Q-learning, deep Q networks, and policy gradients to learn optimal actions in complex environments. Here's how they work. Q-learning is an off-policy algorithm that learns the value of actions in a given state and chooses actions based on these values. These algorithms learn on its own by receiving a reward or a penalty based on the action that it performs. By iterating all the combinations of actions, it will learn to find the most optimum action to take on a certain situation. Reinforcement learning shines in certain scenarios like playing games. In game playing, reinforcement learning has shown remarkable success with models like AlphaGo, which learn to play Go at superhuman level. These models excel in this domain because they can explore millions of potential moves and outcomes, continuously improving their strategies based on rewards and penalties. For robotics, reinforcement learning enables robots to learn complex tasks by interacting with their environment. Algorithms like DeepQ networks allow robots to optimize actions based on trial and error, leading to efficient problem solving in tasks like navigation and object manipulation. The same algorithm can be used for autonomous vehicles, where AI helps in decision making such as lane changing and obstacle avoidance. By simulating countless driving scenarios, the AI can learn to make safe and effective driving decisions in real time. Reinforcement learning is adaptable and can even surpass human capabilities in certain tasks. However, it is complex and requires large amount of data and computationally expensive to work effectively. In conclusion, each of these learning method has its strengths and weaknesses. Supervised learning is all about learning from labeled data, unsupervised learning discovers new hidden patterns, and reinforcement learning learns by interacting with the environment. Each approach is uniquely suited for a specific task, making them invaluable in specific industries. If you find this video helpful, don't forget to like, subscribe, and hit that notification bell for more AI insights. And thank you for staying curious and watching another episode of Artificially Intelligent.